Section 2.4, double and half angle identities. All right, so we're going to talk about some more identities, and these ones are interesting, kind of niche. Um, these are identities like the identities you proved in the previous section. These are known as double and half angle identities. The ones on this page here are double angle identities. The idea with a double angle identity, you can look at their formulas that are here. Um, you have an angle that is double the angles that go into the formula. So let's say you know some information about like this angle right here, this is angle X. Let's say you know like the point on the unit circle, so you know the sine value and you know the cosine value of angle X. But for some mysterious reason, what you're actually interested in is an angle that is exactly twice that original angle, an angle 2x. You want to know the sine value of twice that angle, but all you really know is the sine and cosine values of that original angle. And that's what these identities are good for. Kind of niche, but we can do some fun stuff with them. Um, so for both double angle identities and half angle identities, which we'll talk about in another video, there's a lot of record keeping that you need to kind of keep track of. There's there's the angle X, and then there's the double angle 2x. And then when we get to half angles, there's going to be X and then X over 2. And the sine values, let's go back to that little picture I had drawn here, right? The sine value of this guy right here is going to be different than the sine and cosine, both of them are going to be different than the value of this guy over here. The signs are going to be different potentially, and the values are potentially different. So we have to make sure we're keeping track of which quadrant one of these is in and which quadrant the other one is in. All right, let us begin. I will make a quick mention that this guy right here is actually not a double angle formula. This is just a quotient identity. It's just useful, so I kept it here. Tangent is it's equal to sine over cosine. As long as it's of the same angle, tangent of 2x is equal to sine of 2x over cosine of 2x. All right, so here's how it works. You're asked to find sine, cosine, and tangent of 2x, and you're given information about cosine of x. Cosine of x is equal to 1 over square root 5. X terminates in quadrant 4. So if you look at each of these formulas, I want to find sine of 2x, cosine of 2x, tangent of 2x. All of those require us knowing at least sine and cosine, right? For this guy, we need sine or cosine. Same with cosine. For tangent of 2x, you need tangent. So I'm going to find sine of angle just x, cosine of angle x, tangent of angle x. So here's what we know. We know that cosine of angle x is equal to 1 over square root 5. We know that it's in quadrant 4. All students take calculus. Quadrant 4. So if I'm looking for sine of angle x, cosine of angle x, tangent of angle x, I know cosine, first of all, I know it's 1 over square root 5 is positive, and then everything else will be negative. So sine and tangent will both be negative because we're in quadrant 4. And then I know I normally have you guys like draw a triangle here, but I do that because it's really important to me that you understand, the opposite side, the adjacent side, the hypotenuse, that you understand the difference between all of those. But we can be big boys and girls now, and use our knowledge of triangles to solve for missing sides here. So for this guy here, cosine is adjacent. Adjacent is 1. Hypotenuse is square root 5. Normally, I would have you draw a triangle. But listen, the opposite side is just a leg on a right triangle, right? And we know that a leg is equal to the square root of c squared minus b squared, where c squared is the hypotenuse squared and b squared is the other leg squared. So the opposite side, that's just going to be equal to the square root of the hypotenuse squared, so square root of 5 squared minus 1 squared. That's going to be square root of 4, which is just 2. So the adjacent side is 1, hypotenuse is square root 5, opposite is 2. This is all, again, for angle x, and I can fill in this missing information. So sine of angle x, that's opposite 2 over hypotenuse square root 5. Tangent of angle x is going to be opposite, which is 2, over adjacent, which is 1. So this comes out to just negative 2. Now to find sine, cosine, tangent, I just use these formulas from up here. So I'll start with sine of 2x. Sine of 2x is equal to 2 cosine x sine x. I might have put it in the opposite order in this formula, but that doesn't matter. 2 sine x cosine x or cosine x sine x, the same thing. And I'm grabbing those from right up here. So we have sine, cosine, tangent. We have cosine, sine. So I'm just going to make those replacements. 2 cosine is 1 over square root 5. Sine is negative 2 over square root 5. Multiply those together, you get negative 4 over 5. Sine of 2x. So again, I just got these values off of the information given to us about angle x. For cosine of 2x, you have your choice on formulas. You can use whichever one you want. I'm going to choose to use the last one down here. No reason, it's just the one I chose. 2 cosine squared x minus 1. So we're using cosine. We have 1 over square root 5 quantity squared minus 1. So this becomes 2 over 5 minus 1, which is negative 3/5. So cosine of 2x is equal to negative 3/5. Now, at this point in time, you have options on how you go about getting your last value, the cosine values, because make a square, please. You have your choices here because you can use the tangent formula, or you can use, the fact that tangent is sine over cosine. So using the formula, what it looks like, we have tangent of 2x is equal to, the only real double angle formula is this first one here, 2 tan x over 1 minus tan squared x. 2 tan x over 1 minus tan squared x. So I'm going to plug in the tangent values from right here. We have 2 times negative 2 divided by 1 minus negative 2 squared. So that's negative 4 over negative 3, which is just positive 4 over 3. Tangent of 2x is equal to 4/3. Now, just to kind of prove to you that this would have turned out the same way, I want to say that tangent of 2x is the same thing as sine of 2x divided by cosine of 2x, where sine is this guy right here, cosine of 2x is that guy right there. So this would be negative 4 over 5 divided by negative 3 over 5. Multiply the numerator and denominator by 5. You would get negative 4 over negative 3. You would get 4 over 3. So no matter how you do this, you're going to get that same 4/3 answer there. All right, let's do another two examples here. Find sine of 2x if cosecant of x is equal to 13/12 and x terminates in quadrant 2. So we're only asked to find sine of 2x here. It can help to write the formula down first. I'll write it um, the way that I have it written in the formula sheet now. 2 sine x cosine x. So I need sine x and I need cosine x. We need sine x, we need cosine x. What we know is that cosecant of x is equal to 13/12, and this is angle x we're talking about here, 13/12, and the x terminates in quadrant 2. All students take calculus, quadrant 2. So if I need sine x, oops, it's a thicker pen than I wanted. Boop, 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 boop. If I need sine x and cosine x, sorry, I should be muting that when I go to cough. I'm a little bit sick right now. Um, all right, we're better now. So in quadrant 2, sine is positive, and that makes sense. We know sine and cosecant are soulmates, so sine should just be the flipsy-flu, right, of cosecant, so 12/13. We know because we're in quadrant 2 with x, cosine should be negative. And we need the adjacent side, so let's look here. We have, let's do purple. Cosecant is the reverse of sine. It's the reciprocal of sine. Sine is opposite over hypotenuse. So this is hypotenuse over opposite. What we're solving for, where can I put you? What we're solving for is the adjacent side, which is just a leg. So this is square root of hypotenuse squared minus the other leg squared. And that should be 5. So the adjacent is 5. So cosine, adjacent over hypotenuse, adjacent 5. 5 over hypotenuse 13. So we have our sine value that we need to plug in right here. We have our cosine value that we need to plug in here. So sine of 2x is equal to 2. Sine x is 12/13. And cosine x is negative 5. Put this all together, this should be negative 120/169. And that's our final answer. Boom. Not so bad. All right, one last one. Find cotangent of 2x if secant of x is equal to negative square root 13 and x terminates in quadrant 3. So cotangent of 2x, well, we don't have a formula for cotangent of 2x, but we do have a formula for tangent of 2x. And we know because of the reciprocal identities that cotan of 2x is 1 over tangent of 2x. And really, that's just the flipsy-flu of tangent, right? This is just, it's the reciprocal of this. Instead of 2 over tangent, instead of 2 tangent x over 1 minus tan squared x, it's cotangent will be 1 minus tan squared over 2 tan, right? It'll be the opposite, duplicate, of this. So that'll be 1 minus tan squared x over 2 tan x. The reciprocal. 1 over is the same thing as taking the reciprocal. So I need tangent, right? Need tangent of x. What I have is secant of x. Right? Secant of x is equal to negative square root 13 over 1. Secant and cosine are soulmates. So cosine is adjacent over hypotenuse, which means that secant is hypotenuse. So the hypotenuse is square root 13 over adjacent, which will be 1. We also know that x terminates in quadrant 3. All students take calculus quadrant 3. So tangent is positive there, and that's what we're looking for, yeah, tangent. Tangent of angle x is going to be positive. And we know it's opposite over adjacent, so we need to figure out our opposite side. The opposite side will be equal to the square root of the hypotenuse squared minus the adjacent side squared. So the opposite side should be the square root of 12, which of course can be simplified, but I'm not going to bother. Opposite over adjacent, so we have square root 12 over 1, so just positive square root 12. And we plug into this formula, right? We're going to plug in tangent to these guys. So 1 minus square root 12 quantity squared divided by 2 times the square root of 12. Simplifying this, we have 1 minus 12 over 2 square root 12, negative 11 over 2 square root 12. That's cotan of 2x. Boom. So there you go. That's the basics of these types of problems. It takes a little getting used to, but it really is nothing more than everything you've done already, which is set up your triangle, do the SOHCAHTOA, do the all students take calculus, and then just the additional step is plugging into a new formula. All right. In the next video, I think we're doing half angles. Yeah, half angle identities in the next video, and I'll see you there. Bye.